Hello everyone and welcome aboard the Gerald R. Ford class aircraft carrier, the largest and most advanced of the United States Navy's carriers. This Leviathan of the seas represents the cutting edge of naval engineering and technology. But what is life like on such a monumental vessel? The Gerald R. Ford class aircraft carriers, costing approximately $13 billion each, represent a monumental engineering achievement. These colossal vessels measure over 1,100 feet in length, that's roughly 3 times the length of an American football field, and rise about 250 feet above the waterline, showcasing their massive stature. Designed with the crew's long-term comfort in mind, these carriers are equipped with extensive amenities. They feature large gym areas, multiple grocery stores, and advanced air conditioning systems, all tailored to make life at sea as comfortable as possible. These facilities are not just about comfort. They also play a crucial role in boosting morale among the sailors. The retail service specialists on board manage these facilities, and the revenue generated from sales is reinvested into morale-boosting activities and amenities. With several dining facilities capable of serving around 15,000 freshly prepared meals each day, the logistics of food service on these carriers are as complex as they are critical. Maintaining this level of operation at sea involves a daily expenditure of approximately $65,000, ensuring that all personnel have access to nutritious and varied meals throughout their deployment. Ensuring the operational safety of the Gerald R. Ford class aircraft carriers involves rigorous and routine procedures known as general assessments. These assessments are crucial tools that help maintain the carriers as symbols of naval superiority and national strength. General assessments are vital for preventing accidents, injuries, and illnesses aboard. These regular checks allow the crew to identify potential hazards and implement strategies to mitigate these risks. The process is systematic and aimed at achieving the highest levels of precision and thoroughness. Through continuous training and adaptable procedures, the assessments ensure consistent application across all operations. Routine reviews are flexible yet structured, allowing for the integration of new safety measures as needed. This approach not only enhances safety on board, but also minimizes the environmental impact of the carrier's operations. Risk management aboard an aircraft carrier is dynamic, requiring experienced personnel trained to adapt to varying conditions. The success of general assessments heavily relies on the crew's behavior, awareness, and continuous vigilance. These human elements are critical in the decision-making process, ensuring that each assessment leads to meaningful improvements in safety and efficiency. Maintenance of aircraft on the deck of the Gerald R. Ford class aircraft carriers is a critical component that ensures the functionality and reliability of air operations. This maintenance is complex and vital, pushing the limits of naval capabilities. Given the advanced technology of the aircraft aboard, maintenance operations are intricate and highly structured. The Navy has established rigorous practices that are essential for the safe and timely operation of these aircraft. These practices ensure that despite the complexity, each task is performed to the highest standard, contributing to the overall mission readiness of the carrier. While the majority of aircraft maintenance tasks, such as engine replacements and mechanical repairs, are performed on board, certain operations require the space and facilities available only ashore. Serious corrosion repairs, for instance, or extensive repainting jobs are carried out on land to ensure the best results. Maintenance at sea is categorized into 3 crucial stages: organizational, O-level, intermediate, I-level, and depot. O-level and I-level maintenance tasks are handled directly on the carrier, dealing with daily operational readiness and more significant repairs that can be accomplished aboard. Depot-level maintenance, which includes the most comprehensive overhauls and rebuilds, is conducted ashore due to its extensive nature. Electronic systems and armaments also receive meticulous attention during maintenance. Regular checks and repairs ensure that all systems are operational and any potential failures are addressed proactively. maintaining the highest standards of operational security and effectiveness. Two of the most advanced aircraft operating from the decks of Gerald R. Ford-class carriers are the F-18 Super Hornet and the F-35B Lightning II, each showcasing exceptional versatility and performance that underscore their crucial roles in achieving air superiority. The F-18 Super Hornet is a highly configurable military aircraft capable of performing both fighter and ground attack roles. This versatility is achieved through modular design, allowing for various modifications and attachments. It can carry an array of armaments and equipment from extra fuel tanks to nuclear bombs across multiple hardpoints on its belly and wings. The F-18's high-performance standards enable it to meet diverse mission requirements effectively, making it a valued asset for both the U.S. Navy and Marine Corps. The F-35B stands out with its unrivaled avionics and the powerful Pratt & Whitney F-135 engine, which is among the most potent fighter engines in existence. This aircraft is specifically designed for versatility with a short takeoff and vertical landing (STOVL) capability, allowing it to operate from both traditional runways and the decks of amphibious assault ships. With a range of up to 900 nautical miles and speeds reaching 1,200 miles per hour, the F-35B can perform operations from remote bases with limited space, making it an indispensable component of U.S. Marine Corps aviation. Each unit of this state-of-the-art jet costs over $100 million, reflecting its advanced technology and capabilities. Deck operations are crucial for ensuring these sophisticated jets can land and take off seamlessly. The advanced design of the aircraft carrier's flight deck accommodates the unique requirements of each aircraft, including the vertical landing prowess of the F-35B, which allows it to descend like a helicopter and take off over short distances. Another formidable aircraft with vertical landing capabilities is the AV-8B Harrier II, a key component of the United States Marine Corps' all-STOVL, short takeoff and vertical landing, force. This aircraft has been a staple of U.S. military capabilities since its introduction in the late 1960s and has undergone numerous upgrades to enhance its performance, safety, and range. Throughout its service life, the Harrier has received significant upgrades that have increased its lethality and operational efficiency. These improvements have solidified its role in supporting Marines under challenging conditions and in remote expeditionary environments. With a powerful thrust of 22,000 pounds, the Harrier II can hover like a helicopter and then accelerate to jet speeds, showcasing its unique dual capabilities. This flexibility is crucial for operations on both traditional runways and shorter, improvised landing zones. The Harrier is employed in a variety of mission roles, from air-to-surface attacks and air defense to reconnaissance and support operations. Its ability to carry a diverse array of weaponry, including missiles and bombs, makes it highly adaptable and capable of handling nearly any combat scenario. This versatility allows it to provide comprehensive offensive and defensive support, engage in helicopter escort missions, and perform targeted strikes against both surface and aerial threats. Shifting focus from aircraft carriers and aircraft to another remarkable example of naval innovation, let's explore the USS Zumwalt. This ship is the lead vessel of the Zumwalt-class destroyers, envisioned to significantly bolster U.S. naval capabilities with its revolutionary design and technology. The USS Zumwalt features a state-of-the-art electric propulsion system, a wave-piercing tumble-home hull, and stealth capabilities that minimize its radar signature. These elements make the Zumwalt not just a destroyer but a leap forward in naval warfare technology. Its advanced weapon systems and structural design allow it to fulfill multiple roles, from direct combat to providing crucial support within a naval fleet. With a construction cost of approximately $4.4 billion, the USS Zumwalt stands as one of the most expensive and technologically advanced warships ever built. This investment reflects its extensive capabilities, primarily focused on providing robust anti-aircraft and missile defense to protect the fleet. As a guided missile destroyer, the primary mission of the USS Zumwalt is to serve as a core component of the Navy's surface fleet, offering versatile threat response options, from surface warfare to anti-aircraft defenses. Its sophisticated armaments and sensors enable it to perform these duties across a broad spectrum of operational scenarios. In October 2008, the keel of the USS Zumwalt was laid, marking the beginning of its construction. It was launched 5 years later, in October 2013, but it wasn't until October 2016 that the United States Navy officially commissioned this cutting-edge destroyer into service. The Zumwalt-class destroyers feature a unique, futuristic design, including a back-swept bow and a tumble-home hull that slopes inward, significantly reducing its radar cross-section. Despite its large size, equivalent to 2 football fields, the Zumwalt registers on radar as a small vessel only 50 feet in length. This stealth capability allows it to operate undetected in various strategic environments, enhancing its effectiveness in modern naval warfare. Equipped with 2 turrets housing advanced gun systems that use rocket-assisted GPS-guided projectiles, the USS Zumwalt is well armed for both offensive and defensive operations. Additionally, the destroyer features 80 missile bays capable of launching a variety of missiles, including anti-ballistic, surface-to-surface, and surface-to-air missiles, enabling it to handle a range of combat scenarios effectively. The U.S. Navy continues to invest in the future of naval warfare, conducting research into next-generation weaponry such as railguns and directed energy weapons like lasers. These technologies are being considered for integration into the Zumwalt class to further enhance their combat capabilities and maintain technological superiority. That concludes our look at the USS Zumwalt, one of the most technologically sophisticated vessels in naval history. I hope you found this exploration into one of the Navy's most advanced ships as fascinating as we did. Don't forget to subscribe to our channel to stay updated on our latest content. Thanks for watching, and we'll see you next time.